Okay, to start off this part, I'm going to give you like a little summary of what we are working towards. So it's important that you guys understand that we are still working with inverse functions. So we're still going to change the x and the y around and everything. But the problem we have with an exponential graph is that the form says y is equal to a times b to the power of x. Okay. We're not going to move them up or down. So die eksponensiële grafieke waarmee ons gaan werk, se asymptoot gaan heeltyd op die x-as lê. So we don't have a plus q value there. It's not going to have something like that. Okay. But now what happens when we get the log function is now you have x is equal to a plus b to the power of y. Nee? Stem julle saam? So we need a method to get the y out of the exponent. Want jy kan mos nou nie net gaan sê vierkantswortel nie, want daai is nie 'n tot die mag 2 nie. Okay, so ons korte manier om 'n onbekende uit 'n eksponent uit te haal en dit is waar logs inkom. Okay, so log functions is a way to rewrite something to get an exponent as the object of an equation. So that's what we're working towards. Okay, maar kom ons praat eers net oor die forme van die twee grafieke. Okay, so I'm going to draw the 4 ways that we draw exponential graph. 2 of them are above the x-axis, a stygende en 'n dalende ene bo die x-as, and then 2 of them is when a is a negative value, then they are below the x-axis, but still a ascending and a descending one. So for a bigger than 0, you will have these two functions. So this first one is where b is bigger than 1. And this one is where b is between 0 and 1. Okay, basiese eksponensiële grafieke. Ek sê weer, ons skuif hulle nie op en af nie. So what will the equation of the asymptote of those two be? What 0? Y is equal to 0. Remember, you are talking about the x-axis, maar die vergelyking van die x-as is mos y is gelyk aan 0. Okay. Inverse function still means this. So hierdie een is 'n inverse funksie gaan so lyk. Do you see, instead of having the asymptote on the x-axis, like the exponential graph, it now has the y-axis as an asymptote. Why? Because x and y swaps around. So as die x-as die asymptoot is van die eksponensiële grafiek, dan beteken dit die y-as is nou die asymptoot van die log funksie. And this green one that I drew there, that is a graph of a log function. We'll get to the equation probably only in the next period. Okay, hierdie ene sin gaan so lyk. Also a log function. And then the other two we have is where a is smaller than 0. Kan ek opskuif? Ag, ek haat hierdie. Something like that. Okay, so each time the black graph is the original exponential graph and the green graph is the reflection. Okay, so daai is die vorme van die grafieke. Verder tel al dieselfde goed. Die een se definisieversameling word die ander een se waardeversameling. As daar 'n punt op die een grafiek gegee word, dan lê hy op die ander grafiek ook, maar hy het net geruil, bietjie opgaan. Okay, goed. So al die goeders wat ons nou gedoen het van inverse funksies geld nog steeds. Ons gaan nou net moet praat oor hoe ons nou die vergelyking gaan skryf. So they're still being reflected in the line y is equal to x. Everything else still counts. Okay. Almal happy tot daar?
When you say the graph may not be equal to y.
Graph not equal to x is equal to 0. So not equal to the y-axis, but the definition of the y-axis is x equal to 0. Okay, almal van julle happy daar? Good. So now we're going to talk about solving this problem. Getting that exponent alone. Dat ons met hom kan werk. Volgende periode.